everyone. We're going to continue looking at how do we find position given velocity. And again, what makes this interesting is that we generally won't just be working with constant velocity functions. If we were, distance equals rate times time, we're done. We're looking at velocity changing over time and trying to accumulate distance traveled from that. Okay. So I want to start with, there's a graph at the bottom of this page, but right now I just want to start with looking at the table and pretending that's all the information I have. So I have a car, speeding car, the brakes are applied, its velocity decreases, it takes it 10 seconds to come to a stop. So we start at 100 feet per second, and in 10 seconds we're down to 0 feet per second. So this is the beginning and the end. And I want to do my best to estimate how fast this car is going. And all I have is velocity information that happens every 2 seconds. So we're going to look at 0 to 2 seconds, 2 to 4 seconds, 4 to 6 seconds, 6 to 8 seconds, and 8 to 10 seconds. That's the most information I have. Okay, so for starters, 0 to 2 seconds. Let's see if we can figure out a maximum possible distance. So from t equals 0 to t equals 2, the car travels at most. Okay, so here's what I want to think about. If the car is slowing down, it's initially going 100 feet per second. During the first 2 seconds, it slows to 80 feet per second. The most it could possibly travel, and I don't even know if I would quite say this is possible based on the ways cars work, is if it had maintained that 100 feet per second for the entire 2 seconds and then instantaneously dropped down to 80. Doesn't do that, it gradually decreases. But we're going to use that for an upper estimate. So if you traveled at 100 feet per second for 2 seconds, you would go a grand total of 200 feet. So we do go back to our distance equals rate times time, and to get the largest possible distance, we use the largest rate. We can do this on the other end as well. We can say the car traveled at least 80 times 2, so 80 feet per second for 2 seconds would be 160 feet. So this is all for t equals 0 to t equals 2. If we move on to t equals 2 to t equals 4, now the maximum speed is the 80 feet per second. For 2 seconds, that would get us to travel 160 feet. And now for 2 to 4 seconds, and I can write that down, this is for t equals 2 to 4, we would have a minimum speed of 50 feet per second, which means a minimum distance of 100 feet. For 4 to 6 seconds, our maximum speed is the 50 that we ended with last time, so that would be 100 feet. And this is again 4 to 6 seconds. Excuse me, I don't know if I have a cold or allergies, but I'm all sorts of scratchy voice. The slowest we go during 4 to 6 second time interval is 25 feet per second, which means we go at least 50 feet. For 6 to 8, we go at most 50 feet, since our highest speed was 25 feet per second. Our lowest speed is this 10 feet, so we travel at least 20 feet during the 2 second time interval. And then last one, from 8 to 10 seconds, the fastest we go is 10 feet per second, so we go at most 20 feet. The slowest we go is 0, so we go at least 0 feet. And now we have this sandwiched, and we can add it up and get estimates for our total distance. So let's see if we have 2, 360, 460, 510, 530 feet. And that's going to be greater than or equal to our distance, which will be greater than or equal to, and you can just add this all up, but notice all we've done in comparison to the last one is replace the 200 with a 0. We have all the same numbers otherwise, so we can just subtract the 200 and say this is going to be 330 feet. So now we have this nice upper and lower estimate for the distance traveled. This can be a great answer for a problem like this. If you really want to give just one answer, we'll do a fair amount of just taking those two estimates and averaging them. So we'd say that the distance is going to be approximately 530 plus 330 over 2, which is 430 feet. Okay, so we can estimate distance from velocity just by picking out velocities on shorter time intervals and using distance equals rate times time. It's not perfect, but it does give us an estimate. So down here to the graph, I just want to look at what each of these numbers actually looks like on the graph. So starting with this 0 to 2 seconds, a 2-second time interval, and we ended up with the 200 feet by multiplying that by the 100 feet per second. So down on my graph, the 100 feet per second is going to be this height right here. The 2 seconds are right there, and when we multiply, we're getting the area of this rectangle is our 200 feet. From 2 to 4 seconds, we use the 80 feet per second. So we took the 2 to 4 second time interval, we multiplied by 80, and there's our 160 feet. 4 to 6, we multiplied by 50. So there's our 2-second time interval, there's our 50 feet per second, and that's our 100 foot. 6 to 8, that's 25 feet per second for 2 seconds. Here's our 50, and then last one here, we had 8 to 10 seconds. Our maximum speed was this 10 feet per second, and that gave us a total of 20 feet. Okay, so this is our overestimate, this area that's trapped by these green things. Our underestimate, very similar, except now we're going to use the slowest speed. So for the first 2 seconds, we'll use the 80 feet per second. So this is going to be the blue one. For the next 2 seconds, we'll use the 50 feet per second. For 4 to 6 seconds, we will use the 25 feet per second. 6 to 8, we'll use the 10 feet per second. And then 8 to 10, we'll use that final speed of 0 feet per second. So what you're seeing here is green for upper estimate, blue for lower estimate. And maybe you can start to spot that once again, what we're trying to do is to estimate the area under the curve. That's what we're really interested in. One way to look at that averaging that we did, let me see if I can pick out another color here. I'm going to use red. If you look at this area in here, we're splitting that in half, basically. We're taking the difference between the underestimate, overestimate, we're splitting it. So one way to visualize half of that area is to just draw a line like this, straight down the middle. And you can look at that, and that would be what's happening when you're doing that 430 feet, is if you just split all those in half. There's other ways to look at it. You could split it in half vertically, but this one's really nice because you get that visual on, look at how much closer we're getting to the actual area under the curve. Alright, thanks for watching.